All right, hello everyone. My name is Abhinav Jain, and these are the video solutions for the Troy High School AP Chem Organic Chemistry Timed Practice Test. These are 16 questions. It says give yourself 30 minutes to answer them, but we can do them faster than that. So for number one, which of these compounds have cis-trans isomers? For cis-trans isomerism, we need some alkenes, double bonded. Looking at A, dichlorobenzene, meta-dichlorobenzene. Meta-dichlorobenzene looks like this. Two chlorines matted to each other. This benzene cannot exhibit cis-trans isomerism because the entire ring is planar. Since the entire ring is planar, there can't be any atoms below or above the ring, and therefore there can't be any cis-trans isomerism. So A is incorrect. B, 1-chloropropene. This would be 1-chloropropene. This can have cis-trans isomerism because we can have this chlorine group. This will be a trans, and this will be the cis isomer over here. So then B is our correct answer. And then looking at the other answer choices, we can have uh, looking at C, 1,2-dichloropropane. That's obviously incorrect. Can't have that because there's no alkene. 1,2-dichloroethane, same thing. Um, can't have cis trans for that. 2-methyl 2-pentene. Pentene looks like this. 2-methyl 2-pentene would look like this. We can't have cis trans for this because there's two equivalent groups coming off this carbon, and when we have two equivalent groups, we can't describe it with cis trans. So easy and correct. The answer is B. If certain polymer has this formula, which monomer is it made from? So it has this formula. Drawing it out, we can see it kind of looks like this. Uh, looks like this. Then we keep on going kind of like this. Um, but essentially, with this compound, with this compound right here, which looks something more like this actually. Compound looks like this. If you erase the bond connecting between them and then fold it over, you get this. So redrawn, looks like this. This is the structure of the monomer, so that's consistent with answer choice C. Three, how many different alcohols have the molecular formula C4H10O? So drawing out the alcohols, this is a possible alcohol, 1-butanol. Then we can also have 2-butanol. Then if we have a 3-carbon parent chain, we can have an alcohol like this, tertiary alcohol. Then we can have an alcohol like this. So there's 4 possible alcohols, so the answer is D. 4, what is the oxidation product of this? This is a primary alcohol, as we can see. This is how many carbons? 1-butanol. 1-butanol. So it's going to oxidize to an aldehyde. 5, what bonds are present in this compound? We have a triple bond and then bonds to hydrogen. This bond right here is a sigma bond. This is sigma bond, and then these two are pi bonds. So we have 3 sigma and then 2 pi. Remember, a triple bond is made up of 1 sigma bond and then 2 pi bonds. So the answer is D. 6A, select the structure that can go intermolecular dehydration would produce this ether. So drawing out the structure of this ether, we have O, then we have chain like this. We have a methyl group coming off this carbon. And then off this carbon, there's something similar, like this. So notice how both sides are the same. We just got to hydrolyze this to find the corresponding alcohols that were used. So we slide in a water molecule. We're going to get this and then this as our ether. So this is clearly this is clearly propanol. It's not clearly propanol, like you're saying. This is clearly butanol, 2-butanol, more specifically. four carbons. Then we have butanol, and then two butanol because there's OH is at position number two. So it's two butanol. Right, so the structures that form a carboxylic acid bond oxidation, that's gonna be an aldehyde. So aldehyde F, and then also technically primary alcohols A and F, they both oxidize to the carboxylic acid. Then eight, select structure that is capable of being dehydrated but not oxidized. So dehydrated, compound that would be dehydrated would be an alcohol, but can be oxidized, so that'd be a tertiary alcohol because a tertiary alcohol like this can be dehydrated to form the corresponding ether, which looks like this. There's a tertiary alcohols and tertiary alcohols can be oxidized. So eight is going to be C. C, yep. And then nine, select the structure that is capable of an addition reaction with water to form a product capable of oxidation to a ketone. So we're going to need an alkene to react with water because that's going to add an OH and an H to form this compound. And that can oxidize. This is a secondary alcohol, which can oxidize to a ketone. So we're going to need an alkene essentially. So the answer is E. 10, select the structures necessary to produce a polyester and a condensation reaction. Polyester, that means we need either a diacid and a diol, or an acidol and an acidol. Acidol just being come up with an acid functional group and then an alcohol functional group as well. So we take this molecule right here. This is an acidol. This has a carboxylic acid group and then an alcohol group. None of the other molecules work because this is B. B right here. This is an amino acid. You could really call this technically. So amino acids will not polymerize to form polyesters. They'll form peptides or polyamides. So B is wrong. C, that's an alkene. This is styrene right here. Styrene is going to polymerize to form polystyrene in a radical addition reaction, not a condensation. So C is wrong. D, this is just methanol. Methanol will dehydrate to form an ether, dimethyl ether, which is not condensation to form polyester. So no. E, this is just a diamine. That's not going to form a polyester. So E is wrong. Next up, we have 11. So it says select the structures identical to A. A is clearly a molecule where we have these two groups. They're on the same side of the double bond. Um, so E is going to be the only identical structure because these two are the exact same. And then 12, select the structural isomers to structure D. D has this, looks like this. If we count the chemical formula, you can see that there are how many carbons? 6 carbons, C6. And then how many hydrogens? We're going to have 6 plus 3, so that's 9 plus 11 hydrogens, so C6H11 and then Br. Looking at this compound, this is also C6H11 Br. Then looking at the other compounds, this is also C6H11 Br. This compound and this compound are not geometric isomers, they're structural isomers because this ethyl group is now on a different carbon. Before it was on this carbon, now, before it was on this carbon, now it's getting switched to this carbon. So the correct answers are B and C. And 13, select the geometric isomers to structure A. A looks like this. Geometric isomer would be flipping one of the ethyls or one of the bromines. That would be consistent with D. So answer is D. And then 14, select your structures incapable of geometric isomerism. So C is incapable because we have an ethyl group and then an ethyl group coming off the same carbon. When you have two equivalent groups coming off of one of the carbons in the double bond, then you can't have cis trans isomerism. So C is one of the right answers. And then B can have cis trans isomerism technically because the bromine atom can be either above the ring or below the ring. It's not really possible to have cis trans isomerism for B, so it really should be B and C. But the answer, he does say B and C, so yeah, B and C are both not possible because again, these are two hydrogens coming off this carbon, and we have two equivalent groups. That means you can't have cis trans isomerism. So the answer is B and C. All the other ones have non-equivalent groups on both carbons. So you can have cis trans isomerism. 15, which monomers are needed to make the polymer shown above? So if we hydrolyze this polymer to find the monomers, we can clearly see uh, that we just draw it out like this. This is our acid that we used, and then this is our alcohol that we used. So we use this alcohol 1, and then we're going to have to use 1 and 2. This is the corresponding carboxylic acid. So the answer is 1 and 2. So C. When C4H8 is treated with water and H2S4 tertiary alcohol is produced, what of the following could represent C4H8 in this reaction? So C4H8 reacting with water and H2SO4 catalyst makes an alcohol. That's going to be a hydration reaction in which an alkene is being hydrated to an alcohol. So we can look at all the alkene products. We're going to have A, B, and C as possible. And then it's making a tertiary alcohol. So it's going to have to be this one because if you react this one with water, it's going to form this compound. You can clearly see that this is a tertiary alcohol. So the answer is C. That is the all the solutions for the practice test. Good luck on your test. It's coming up soon. This isn't a difficult one. Just gotta think, not make silly mistakes. And yeah, if you're struggling on chem in the future, don't be afraid. ACE is always there. If you need some extra help. Otherwise, we're gonna be making these practice test solutions for all the practice tests and all the timed practice tests throughout the year for each unit. So yeah, stay tuned on this channel.